Hello, once again, folks. Welcome to the Unit 7 test part 1 review. So the test will be two parts, kind of a multiple choice regular test and then a free response version on part 2. So we're going to do part 1 right now. So a lot of these questions are going to be similar to what you'll see on the field test. Keep that in mind. They're not the same, they're similar. When a fair die is rolled, the probability of any side landing face up is 1/6. Which of the following is the best interpretation of the probability of rolling a 5? So of course, there's six sides to die, so the probability of rolling a 5 should be a 1 in 6 chance, right? So let's see which of these makes the most sense. When you roll a die 6 times, exactly one time a 5 will land face up. Well, we know that this isn't a guarantee, right? Um, a 5 can land no times 6 and 6 rolls, right? It could land once or twice in 6 rolls. So yeah, no, the word exactly there is problematic. If you roll a die 600 times, exactly 100 times a 5 will land face up. Again, the whole exactly thing is a bit off. It's not going to be exactly. It could be a little higher or a little lower, right? As you roll the die over and over many times, the number of times that a 5 will land face up out of the total number of rolls will get closer and closer to 1/6. This sounds right because this sounds like the law of large numbers, which is true. And the last part, if you roll the die twice in a row and both times a 5 landed face up, the next time you roll, you're less likely to roll a 5 because rolling a 5 should happen only once every 6 rolls. So that's of course false because the probability hasn't changed. Probability is always 1/6 no matter what, right? It could land 5 times in a row. It's still 1/6 for the next roll. A spinner with exactly three a spinner with three equally likely sections is spun 2 times. Each section, I have a stuffy nose and it's hard to say stuff sometimes, has a different number from 1 to 3. And the number of threes spun is recorded. Find the probability model for this chance process. So basically we're just trying to put all possible outcomes here. So we're just going to list them off. So I suppose we could do a 1, 1, a 1, 2, a 1, 3, a 2, 1, a 2, 2, 2, 3, a 3, 1, a 3, 2, and a 3, 3. Or if you spin it twice, right? These are all the possible outcomes of getting, 2 spins. Okay. Cool. So probability model, right? Just all the outcomes listed there. It probably should also mention that each of these has a 1/9 probability, right? So it might also be included on the table that this is a 1/9 chance of happening, 1/9 chance of happening for all of these. So just to keep that in the back of your head as well. All right. For the upcoming school fair, each ride requires from 0 to 3 tickets to ride. The probability distribution of the number of tickets needed for randomly selected ride of the fair is shown below. So what this kind of translates to is right here, it's saying essentially 10% of rides cost 0 tickets. About 20% of rides cost 1 ticket, 30% of rides cost 2 tickets, and 40% of rides cost 3 tickets. That's kind of what this is talking about. What's the probability at least 1 ticket is required for the ride? So at least 1 ticket, that's 1 or more. So if you add them up, right? 0.2 plus 0.3 plus 0.4, you get 0.9, right? Alternatively, by the way, You could just do 1 minus the probability that there are 0 tickets needed, 1 minus the probability of none, which in this case is 1 minus 0.1, which is still equal to 0.9. So you can add up these probabilities, which do exist, so that's not too difficult, or you just 1 minus this. So either way, you get 0.9, but I wanted to point that out. Number 4, the teachers at a local high school were surveyed. Two of the variables recorded for the 150 teachers were housing status and length of service. Housing status was recorded as owning or renting your residence, while length of service was classified as new teacher, less than 5 years, or experience, at least 5 years. The following table summarizes the responses. So we have teachers who own or rent houses, and then whether they're new or experienced. So you can see like there's 5 teachers who are new and own a house. There are 25 teachers that are new and rent a house. That's 30 teachers in total, 30 new teachers in total. Experience, you can see there's 75 experienced teachers that own a house, 45 experienced teachers that rent a house. That's a total of 120 experienced teachers. And as you can see, of all the teachers, 80 teachers own houses and 70 teachers rent houses. So based on the responses, what is the probability that a randomly selected teacher from this school is a teacher who has less than 5 years teaching experience or who owns their own home? So probability of 5, um, basically new, right? Less than 5 years is probability of new or owns their own home. So remember, this is the probability of a new teacher plus the probability of owns a home minus probability of new and owns a home using that formula that we've talked about before. The formula I am referring to, and it's still written on our board, is probability of A or B equals probability of A minus probability of B minus probability of A and B. So let's look at the numbers here. And you're going to see new, we have 30 new teachers plus owns a home. We have 80 people who own a home, but then minus the overlap, minus the and people who are new and own a home. And that's 5. And so when you tally this all up, this comes out to equaling 110 minus 5. So this is 105 out of, don't forget, 150. So 105 out of 150. Let's quickly calculate that. Where's my calculator? So 0.7, 70%. All right. So, you guys, we've struggled with this formula a little bit. It's not that complicated, it's you put 3 numbers together and then you divide it out of the total. Just all you gotta do is remember the 3 values. The total for this value, the total for this value, and then minus the value that they overlap at. So the total of new, the total of own, and then the overlap of new teachers owning, right? So hopefully you can keep that together. At a local high school, 30% of students are on a school sports team. 25% of the students take at least one AP class. 10% of students are on a sports team and take at least one AP class. If a student is randomly selected from this school, is the probability that a student is on a sports team or takes at least one AP class? All right. So let's see here. Let's break this down. 30% of students are on a sports team. So probability sports equals 0.3. 25% of students take at least one AP class. So probability of AP equals 25. And 10% of students are on a sports team and take at least one AP class. So this is overlap. Probability of S and AP equals 10%. So that's all the information that they gave us. So it's asking the probability a student is on a sports team or takes at least one AP class. So again, there's your or word, right? It's the same formula that we talked about on the last one. Probability of S plus probability of AP minus probability of S and AP. Because it's or again, right? Same thing. Probability of A or B is just putting these three amounts together. So when we put it all together, we end up having 0.3 plus 0.25 minus 0.10. And this comes out, and there's no dividing here because it's already in probability format, right? You can see in the last one, they weren't in probability format, right? These were just the numbers of people. So that's why we took it out of 150 and made it probability. But these ones are already the probability, right? They're already in decimal form. So you just got to put them together. And so this comes out to 0.45. All right. So a lot of reading, but take your time there. It helps to kind of point out, like really emphasize what each of these was, because when you read it one time through, it gets a little confusing. But when you focus on it slower, it makes it a little bit easier to understand, like, oh, this is that, this is that, this is that. And all you gotta do is just put them together, right? In a large city, the city permit office noted that 30% of residents owned cats, 55% of residents owned dogs, and 10% of residents owned both cats and dogs. Let's C represent the probabilities randomly selected resident owns a cat, and D represent the probabilities that randomly selected resident owns a dog. Draw a Venn diagram for this situation. Find the probabilities of randomly selected resident does not own either type of animal. Okay. Zoom in a little bit. Dog, cat. Now we're gonna start with the both. It says 10% of residents own both, so we know that this is gonna be 0.1 in the middle. 55% of residents own dogs. So with that 10% already there, we're gonna have 45 here, right? 45 and 10 makes 55. Cats, 30% of residents own cat. We already have 10% there, so this will be 20%. All right. So remember, this all should add up to 1. So we have 0.45 plus 0.10 plus 0.20. This comes out to 0.75. So that means we have 0.25 out here because 0.45, right? 0.45 plus 0.10 plus 0.20, and then plus 0.25 equals 1. So our answer, there's our Venn diagram, and our answer is 25% don't own either. All right. Number 7, the teachers at a local high school were surveyed. Two of the variables recorded for the 150 teachers were housing status, length of service, same table we have from before, as you can see. Based on the responses, what is the probability that a randomly selected teacher from the school is a renter if we know that the teacher has less than 5 years of teaching experience? So it says given, basically, we know they have less than 5 years experience. So this is the probability that they are a renter given that they are less than 5 years, so given that they're new. So as you remember, right, hopefully you remember, this would be the probability of being renter and new over the probability of just new. So we're just going to look for these totals. Renter and new teacher rents, that's 25. So we have the top number here is 25. And then our denominator out of the total of new, our total of new is 30. So it's saying, hey, look, we know that they're a new teacher. So we know we're talking about this group of people here, right? We're focused on, hey, look, they're a new teacher, right? So we're looking at this group of people. So everything else can be completely ignored now. If we know they're a new teacher, what's the probability they have less than 5 years, or what's the probability they're a renter, right? Well, as you can see, 25 out of the 30 here, 25 out of 30 of those teachers are renters, which comes out to, when we just divide these, by the way, 25 divided by 30 comes out to 0.83. All right. Number 8. A survey of all the students at a school revealed that 30% of students drive to school, 80% of students have at least one sibling, and 24% of students drive to school and have at least one sibling. Are the events driving to school and at least one sibling independent? So remember, let's identify first what we have here. So 30% of students drive to school. So probability of drive equals 0.3. All right. We have 80% of students have at least one sibling. So, oh my gosh. Probability of sibling equals 80. And 24% of students drive to school and have at least one sibling. So probability of driving to school and having a sibling equals 24%. All right. So here's what we're looking for. Um, we have our options really. So our goal is to decide if probability of driving is equal to probability of sibling given driving, or alternatively, we can find the probability of sibling equals probability of someone driving giving sibling. Oh wait, hold on. I had those backwards. Driving given sibling or sibling giving driving. So again, this is one of those rules that I have on the board. Um says, independent if there's these three that go together. So this is what we're gonna stick with. Basically just remember we have driving compared to driving with a sibling. We have a sibling compared with sibling who drives or with driving. So either one of these works. I'm just going to stick with the first one. We have enough information to answer it either way. So we already know, like if we stick with this first one here, probability of driving, we already know is 0.3, right? So the question is, we're going to try and decide if it's equal to the probability of driving giving a sibling. So that probability of driving given a sibling, is probability of driving and sibling. Remember, conditional formula, driving and sibling, over probability of sibling, the second part to it. Now driving and sibling is 0.24, and sibling itself was 80. So look and see if 24 out of 80 is also 0.3. So if you take 0.24 out of 80, 0.8, you get, comes out to 0.3. So it turns out that they are equal to each other, which means that they are independent. So yes, independent. All right. Now I want to show you just the alternative real quick, just real fast. Um, and I'll have to erase it because I'm gonna write it in number 9. But if you did do it the other way, probability of sibling equals probability of sibling given driving. You know, probability of sibling is 0.80, as it says up above there. And sibling given driving would be probability sibling given driving equals probability of sibling and driving over probability of driving. Um, so remember on these, the second part is the denominator. So given sibling, sibling is denominator, but here it's given driving, so driving is the denominator. But in this case, it would be 0.24 over driving, which was 0.3. And if you divide those, 24 divided by 30, 0.24 divided by 0.3, you get 0.8. So again, 0.8. So you can see these are equal to each other either way you do it. Okay, so I just wanted to show you that. Again, these formulas are on the board. It's just a matter of knowing how to equate them, right? Find out what they're worth and then answer the question. Of all the lights manufactured at a certain factory, 95% of light bulbs work and 5% are defective. If 6 light bulbs are selected at random from all the light bulbs, what is the probability that all of them work? So 6 light bulbs are selected from all the light bulbs. What's the probability that all of them work? So it's all 6. So that's working, 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 working. Oh my gosh. Working and working, all 6. And remember, 95% chance that they work. So this is 0.95, 0.95, 0.95, 0.95, 0.95, etc. So you just multiply these all together. It's basically 0.95 to the 6th power. And we get, let's see, we get 0.74. So 74% chance that all of them work. All right. If you play chess with a friend, and from past experience, you know each game is independent. You estimate the probability that you win a game to be 60%, so 0.6. If you plan to play 3 games against your friend, what's the probability you win at least 1 game? So probability of at least 1, as you know, is 1 minus the probability of none. So I want to find the 1 minus the probability of winning no games. So the probability of none winning no games means you lose all 3. Lose all 3, which means it'd be a 0.4 times 0.4 times 0.4. Right? You lose, you lose, you lose. 40% chance you lose, 40% chance you lose, 40% chance you lose. So probability of none, 0.4 times 0.4 times 0.4 is 0.064, 0.064. That's the probability you lose all 3. Probability of winning none, 0.064. So the probability that you'll win at least 1 is 1 minus 0.064, which is 0.936. All right. Alessandro, a graduate student at a local college, is picking a suit to wear to his job interview. He has to decide among the following options: blue, white, or red shirt, blue or black pants, and a tie that is either striped or solid. How many different combinations does Alejandro have to choose from? Well, he has 3 shirt options, 2 pant options, and 2 tie options. So he has 3 times 2 times 2, which is 12 options. Don't overcomplicate questions like that, right? Just the number of options times each other gives you the total amount of options. We talked about that recently. All right, number 12. 5 friends are going to the movies and will sit in 5 consecutive seats. One of the seats is One of which is one of which is one the aisle. I think it means on the aisle. In how many ways can the friends sit in the 5 seats? So it's a different order, right? So you have seat 1, seat 2, seat 3, seat 4, seat 5. So there are 5 ways for the first person to sit in the first seat, but then when that person sits, there's 4 ways for the second person to sit. And when those two are sitting, now there's only 3 people left to choose from for the third seat, right? 2 people left to choose from for the fourth seat, and then 1 person left on the last seat. So this comes out to 5 factorial, which is, I want to say 120. Yes, 120. 120 ways. 10 singers have signed up for a singing competition. The order in which they will compete is selected by random draw. 5 of the singers will compete before an intermission, and 5 will compete after the intermission. How many different ways are 3 of the 5 singers to be selected to sing before the intermission? So basically, it's a permutation. So you have 5 permutation 3. You've got 5 singers to choose from, and you're going to pick 3. Hold on, just make sure I read this one more time. Yeah, I don't know. The question's worded weirdly, but all this stuff is ahead of the question. But once it says how many different ways are 3 of the 5 singers to be selected to sing before the intermission, it's 5 choosing 3 here, which if you use you can either type that in the calculator this way. You could also do it as 5 times 4 times 3, right? You can figure it out this way. It's 5 factorial over 5 minus 3 factorial, which again simplifies to 5 factorial over 2 factorial. Which again just means I'm showing you all this stuff that the 2 and the 1 cancel out. Either way, it's still 5 times 4 times 3. Whether you use the formula, this permutation function in the calculator, you're welcome to use as well. Or if you just do it the old school 5 times 4 times 3, right? There are 3 singers, and there are 5 in total. There's 5 to choose from, but you're choosing 3. So for the first singer, there's 5 people to choose from. For the second singer, there's 4 people to choose from. From the third singer, there's 3 people left to choose from. So we end up with 60 ways to do it. All right, a teacher randomly selects 3 students each month from a class of 30 students to be the student of the month. Each student receives a special certificate, a special seat in class, and a free homework pass. How many different groups are of 3 students could be selected? Now this one's where order doesn't really matter, right? How many different groups of 3? So order doesn't matter, making this a combination question, not a permutation question. So you're gonna have to remember it's a little bit different than what we did number 13. Well, hold on. Let me take that back a second. So if I read this question again, a teacher randomly selects 3 students each month from a class of 30 to be students of the month. Each student receives a special certificate. Oh no, so this doesn't matter. Each student receives those. I was wondering if one student received that, one student received that, and one student received that, then order would matter because I could pick 3 students, but they could have different combinations of this. So, but no, it doesn't matter because each student gets that. So this next part here is really meant to just mislead you. It almost confused me, right? So it's really not relevant. So you have 30, you're going to choose 3 students, and it doesn't matter the order. So it's a combination of 30 choosing 3, which you can use type that in the calculator is probably the easiest way of doing it, or use a formula, which is 30 factorial over 3 factorial times 30 minus 3 factorial, which is 30 factorial over 3 factorial and 27 factorial. However you want to do it, Um, it comes out to, let's see here. Oops. 40 or 4,060. 4,060. The math department at a high school has 7 teachers, 4 females and 3 males. 2 of the teachers will be randomly selected to go to a math conference. What is the probability that both of the teachers that are randomly selected are female? Okay, so this one's an interesting one because it's probability. These are going to be kind of tricky. So we have, first we want the basically female versus overall is what we're going to kind of look at here. Female and then out of all. So the probability of choosing 4 females, right? We're choosing 2, but the probability of choosing 2 from the 4, so we'd have, it doesn't matter order here, so it's a combination. We have 4 choosing 2 for the females, but over, if I choose 2 people out of 7 in general, this is the all part. So 7 teachers in total, but we're choosing 2, 7 choosing 2 for the combinations. So basically I'm finding out how many ways can I select 2 females from 4 females, and then how many ways can I choose 2 people from 7 people, right? So it's female over all. That's how I kind of describe it. I'm choosing 2 females from the 4 females. I'm choosing 2 people from all 7 people. So it's basically just, this is out of the females. This is out of everybody. And when we work this out, let's see here. If I do 4C2, I have 6 up here. And then 7C2, I have 21 here. So it's 6 out of 21, which is 0.29. So 29% chance that they would both be females. All right. According to the National Center for Health Statistics, in December 2012, 60% of US households had a traditional landline, 89 had cell phones, and 51% had both. Suppose we randomly select a household in December 2012. What is the probability that the household has a traditional landline telephone or a cell phone? So it's one of those ors again, right? Probability of traditional, and then it says or cell phones or cell phone. So remember, this would be the probability of traditional plus the probability of cell phone minus the probability of traditional and cell phone, which it gives us all those numbers. So probability of traditional, 60%, so 0.6, plus probability of cell phones, 89%, so 0.89, minus probability of both, which is 51%, 0.51. So just piecing all that together now. This equals, let's see, 0.6 plus 0.89 minus 0.51 equals 98. Basically, 98% of people have a phone of some sort. All right, so again, that's just the formula we've referred to a couple times earlier. Happens again there. Make sure you know these formulas, okay? They're definitely going to be used quite a bit. All right, that's going to be doing it for part 1. I'll see you guys for part 2's review later. Bye for now.